This is a basic guitar pickup. You can use them, you can attach them to a guitar, and when you play the instrument, it picks up the mechanical energy from the strings vibrating and converts it into electrical energy. And you connect it to the input of an amplifier, and it'll play music. So when you flex it or tap on it, again, the crystals convert that physical energy into electrical energy. This demonstration shows that when you press down on the piezo, you get a negative voltage, and when you release, you get a positive voltage. This shows the piezo hooked straight up to an LED so that when you tap it, one LED flashes. If you have two LEDs hooked up, reverse polarity, then they'll alternate when you're hitting the piezo. This shows two LEDs hooked up to the same piezo with reverse polarity. When you tap it, it looks like both lights are flashing at the same time. In actuality, if you pick up the piezo and flex it, you can see that they're alternating.
Can you?
Here we have the piezo hooked up to a oscilloscope. You can see when you hit the piezo, you can easily generate spikes of 100 volts. When you flex the piezo, you only get about 5 volts out of crystals. Now when I have the piezo hooked up to a resistor, 2.2 kilo ohm resistor, when I tap the piezo, I can produce about 10 volts. When connecting the piezo to a 2.2 kilo ohm resistor and flexing it, you make a wave with about half a volt peak to peak. Here we have a basic piezoelectric energy harvesting circuit. We have two piezos to help charge the capacitor twice as fast. You can use as many piezos as you want. Here's a diode circuit. There's two diodes facing one direction, two diodes facing the other direction. Basically, when you flex the piezo, the positive charge goes to the positive side of the capacitor, the negative charge goes to the negative side of the capacitor, and you charge twice as fast. And then the capacitor that we're going to store the charge on.
This is a diagram of the simple piezo energy harvesting circuit that we have designed for this experiment. The piezo generator guitar pickup is on the left, and it feeds into a diode rectifier circuit. This allows us to store charge produced in both directions of the deflection of the crystal. It also has the added benefit of converting our AC voltage into DC voltage, which is more appropriate for storage in a battery or use in a low power sensor. The output of the rectifier circuit goes to the capacitor. In this experiment, we're using a 100 microfarad capacitor with a 25 volt working voltage. Later, you will see us close the switch and feed the energy stored in the capacitor to an LED. The 2.2 kilo ohm resistor is there to slow the rate of light discharged from the LED.
So as you hit or tap the piezos, you see the voltage increasing on the voltmeter. The capacitor we have is rated at 25 volts, so anything over 25 volts is just wasted energy. Once you hit a certain voltage, you can attach a sensor, or in this case we'll attach an LED with a resistor and show how it lights it up for a second. So we charged up the capacitor to 10 volts, took maybe 30 seconds with two of the piezo discs, and when you touch the LED with the resistor, it should light up for a second.